Hey everyone, this is a chapter on time and work. This topic is very much related to ratio and proportions. The questions that are asked from this chapter are the ones similar to this one shown here. You have some worker who does some piece of work in some days. So you will be asked in how many days will he complete the total work. Or you may have two people working on some work and some time is given for them to complete the work. And you will be asked what is the contribution of each of the worker or something similar to these questions. So what we are going to do is we are going to first learn the formulas that are necessary for us to solve these kind of questions. So here we have, if A can do a piece of work in n days, then what is A's 1 day work? So we have two quantities here, work done and time taken. Let us assume that the work done or the complete work done in n days is 1. The value is 1. So the days taken are n days. That's what given to us. And we have been asked what is A's 1 day work. So the days taken is 1. What is A's work done? Let it be x. So this is basically a direct proportion because the more work is done, the more days are taken. So we can actually equate these ratios. So we have x is equals to 1 by n. So the work that A does in 1 day is equal to 1 by n. Now why did we take this complete work done as 1? Well, consider that A can do the complete work in 2 days. Now A's 1 day work will obviously half of the work, right? A's 1 day work gives us the fraction of the total work done. So had we considered this as something like W, A's 1 day work would have come out as W by n, so we would have got incomplete answer. So that's why we take it as 1. This is an important formula, you should remember this. Now let us look at another formula. If you have been given A's 1 day work as 1 by n, then what is the number of days in which A can finish the work? Now again you have work done and the number of days, and obviously work done is directly proportional to the number of days. Okay, so the work done in 1 day is 1 by n, so 1 by n and 1 days. Then you have been asked the number of days in which A can finish the work. So let these number of days be x, and it is said that in these number of days A can finish the work. So the work done is the complete work done, and that we always assume as 1. So now we have the ratio and we can equate it. So 1 by n is equals to 1 by x. Therefore x is equals to n. So it takes n days to finish the work. So this is another formula. Let us solve this question now. We are not going to use the formulas that we've seen here. We will solve it traditionally. So worker A does 1/5 of the job in 8 days. In how many days will he complete the work? Now again you have work done and days taken, and these two quantities are proportional. So 1/5 of the work is done in 8 days. Now in how many days, so let us consider this as x, will he complete the work? So the total work done is usually considered as 1. So we have the ratios, we can equate them, and we can find the value of x. So we have 1 by 5 is equals to 8 by x. Therefore x is equals to 8 times 5, that is 40 days. So the total work done is in 40 days. Let us solve another question. This one is very important. So worker A takes 8 days to do a job. Worker B takes 6 days to do the same job. If A and B work together, how long will it take to complete the work? Well, worker A takes 8 days to do a job. So we can find out the total work done by A in 1 day. And we know the formula. If A can do some piece of work in n days, then A's 1 day work is 1 by n. Now A takes 8 days to do the job. So work done by A in 1 day will be, according to the formula, 1 by 8. Now worker B takes 6 days to do the same job. So work done by B in 1 day is equal to 1 by 6. Now it has been asked that if A and B work together, how long will it take to complete the work? So we have the work done by A and B in 1 day. So in 1 day, if they work together, the work done will be the addition of these two terms, these two work done by A and B. So we have 1 by 8 plus 1 by 6. So this is equal to 7 by 24 in 1 day. So we have the work done by both of them in 1 day, and we have been asked how long will it take to complete the work. So let us write the work done and days taken, which is proportional to each other. So we have 1 day's work as 7 by 24 if they work together. So in how many days will they complete the work? So the complete work done is considered as 1, and this is directly proportional, so we can divide and equate. So what we have is 7 by 24 is equals to 1 by x. So therefore x is equals to 24 by 7. And that's the amount of time that's going to take if A and B work together to complete the job. Let us solve another question. You have it given that A is twice as good as a workman as B. What is the ratio of time taken by them to do the same work? Now let us consider that the work done by B is equals to 1. The complete work done is 1. Now let us say that this is done in n days. Now the work done by A will be equals to A is twice as good as B. So A works more than B, right? So A's work will be 2 in the same time period. Now we want the ratio of the time taken by them to do the same work, but we do not have the same work done here. B works 1 and A works 2. So we gotta make this work of A as 1. So if A works 2 values in n days, so if he works 1 value, what will be the number of days? Well, it will be n by 2 days. Now we have the same amount of work done and the amounts of time taken to do the works. So we can now take the ratio. So the ratio is A by B, so n by 2 by n, and that's gonna give us n by 2n, and the ratio will be 1:2. So this is the ratio of the time taken by them to do the same work. Now this leads us to a conclusion or a law or some formula. If the ratio of work done by A and B is x:y, then the ratio of the time taken to do the same work is the inverse of this ratio, or is the reciprocal of this ratio. So if the ratio of work done is x:y, then the time taken will be opposite, y:x.